You have just read about how the brain processes information. As you watch this video, keep the following questions in the back of your mind. How does the brain's method for interpreting sensory information influence learning? How can I structure my lessons to get past the brain's natural filters? In many ways, we can think of the human brain as a black box. Sensory information is gained from our eyes, nose, mouth, skin, and ears and carried to the brain. The brain then takes this information and helps us make meaning out of it. It tells us why information is important or not important and how we should react to it. Here we will explore the inner workings of this black box and better understand how and why it operates. As you already learned, thoughts are really just electrical impulses carried through the brain. This is also true about sensory information. When we touch something, that feeling is converted into an electrical pulse that passes through our bodies and up to the brain for processing. The problem is, even when we sit still and do nothing but breathe, our bodies are still taking in enormous amounts of information, from the feel of the ground under our feet to the sound of birds in the distance. The brain is simply not capable of processing all of the data that enters in at one time, so it has a screening system. It automatically filters through the sensory data and figures out what's most important, and then lets the unimportant things drop out of the system or get processed in the background, subconsciously, without our full attention. This screening system is run by the thalamus and the portion of the brainstem known as the RAS, or the reticular activation system. Here's how it works. All the information that enters our body, with the exception of smell, passes through the thalamus the moment it enters our brain. The thalamus sifts automatically through this information to find out what's most important to the body's survival at that moment. If, for example, the information being processed was the sound made by a dangerous animal approaching, then this information would get priority. The thalamus knows that this information is most important because it has learned over the years that the growl of a tiger is dangerous, and also due to basic human instinct. The majority of the information processed by the thalamus is deemed as being unimportant. Unimportant information drops out of the system, and you will probably never even realize the information was ever carried to your brain in the first place. Thanks to this first filter, known as the sensory register, the brain now has much less information it has to process. The information that does make it past the first filter passes from the thalamus to the cortex, where we start the process of converting it into a memory to be stored in our brain. It might become immediate memory. This is a place where we put information briefly until we make a decision on how to either use it or dispose of it. Think of it as a type of clipboard, where input is placed briefly before it is shuffled to another location. If after about 30 minutes this information isn't deemed important, it is dropped from the system. This process occurs subconsciously. In other words, it happens without you realizing it. Another kind of memory is called working memory. Like immediate memory, this is a place where we store information for a short period of time. But unlike immediate memory, working memory includes a conscious process. You actively start to take apart the information being stored here and build new ideas out of it, manipulating it so that the meaning of one thing might connect to the meaning of another. Our working memory capacity changes over time, becoming larger and larger until the age of about 7. And this has huge implications for the way we teach younger children. These children cannot deal with complex numbers, concepts, or multiple sensory inputs as well as older children can, simply because their working memory is still developing. Once the information is in short-term storage, either as working memory or immediate memory, the brain has to decide whether or not that information is important enough to keep around in its long-term memory, or if the information should be filtered out. If the information is seen as being important to survival, then it's kept around. And if there's a strong emotional resonance with the information, if it makes us feel very happy or very sad, it will also probably make its way into long-term memory. Our goal as teachers is to help students convert important information, whether it's math or science or reading, into long-term memory. That's what learning is. The problem is, most of the concepts we deal with don't have a huge immediate impact on survival. Your brain does not see algebra as vital to life. Similarly, algebra does not usually create a strong emotional response. Very few people get excited about the prospect of variables. This means that in one sense, the way the brain works makes our jobs more difficult, as it is actively trying to filter out the information we are trying to pass on to our students. And knowing that, we can come up with strategies to make sure our information gets past the brain's automatic filters. There are two questions students unknowingly ask themselves in the classroom when learning new material. Does this make sense? And does this have meaning? If the answer to either one of these questions is yes, then there is a greater likelihood that this information will make it past the brain's natural filter. Does this make sense is another way of asking, does my student understand and embrace the topic I am asking her to learn? Can she duplicate this process in a new setting? If I give her one algebraic equation, can she figure out how to solve another? If the answer is yes, then the information will likely enter long-term memory. Does this have meaning is a slightly different question. This is another way of asking, is this information relevant to my life? Can I tie this concept to other concepts or emotions already stored in my brain? Information that has meaning to a student has an even higher likelihood of entering long-term memory. For us as teachers, this means that our goal should be to make sure our students fully understand the concepts we're teaching them, and that we should make sure that we are teaching these concepts in a way that is relevant to their lives. We should, if possible, make them feel some emotion associated with the material. These are the best ways of getting around the brain's built-in filter. Let's review. In this lesson, you learned that our brains are constantly taking in information through our senses. You learned that there is simply too much information being taken in for the brain to process all of it, so it is equipped with natural filters. You learned that the first filter is the thalamus. From there, information is converted into immediate memory and working memory. Immediate memory is a subconscious process, while working memory involves taking apart ideas in a conscious way. You learned that working memory changes over time until the age of about 7, so it's important not to expect young learners to tackle complex concepts because their brains are not yet able to do that. You learned that information that makes it past these short-term memory filters becomes long-term memory, and that most memory stored here is either useful to ensuring survival or it has a high emotional resonance. And you learned 2 strategies for making sure information taught in the classroom is transferred into the long-term memory of your students. When students ask themselves, does this make sense? Or, does this matter? The answer should always be yes. Remember the questions that you asked yourself at the beginning of this video. Now is a good time to answer these questions. Once you have done that, apply your answers to the themes of this video.